practice we are going to create a sample. We are going to learn how is the procedure of creating the bakelite in order to do a metallographic analysis. It is very important this practice because with this we can know how it's going to develop the aluminum and the steel when it gets into the industry.
I'm out of excuses, I know it was.
We are going to cut these two metals. This is steel and this is aluminum with the help of this cutting machine with a disc. These two blue tubes throw water and oil, and this water and oil helps to cool the metal while it's cutting.
We're going to cover this metal with a thermoset that is called bakelite. For this, you have to put this little metal over the platform that is in here. Then you're going to use a funnel to put a spoon of bakelite. Then you're going to put it downwards and you're going to close it with this. Afterwards, you're going to use the resistance to put heat on it, and then you have to wait 10 minutes. For those minutes, you have to wait until all the time the arrow has to be at the point red. Then all the teams are going to obtain something like this. We put it in a machine like this, and it has to have a little platform over here, and then we all put all the bakelites and the metals in here just to do this and left them all at the same space. Then the same bakelite already on the same level, we're going to put it over here, and this will move, sanding the metal.
After we sand the bakelite with the metal, we pass the base through the polished part. We polish these things, rotates, and as we rotate, they polish the metal to give a finish like this, a mirror finish.
Then we're going to clean the metal with this liquid that is used for a chemical attack.
We put the bakelite with the metal here, and with help of this optic lens, we can see the metal here in the screen.
The importance of metallography in the industrial sector is that with the study of the materials you can have more knowledge about one simple material or one simple element, and you can create more elements or create a new material that can adjust to your necessities, and you can make the material durable, resistant, ductile, or the specifications that you want in that part. The assignation number of the sandpaper is the number of grains per inch square, and if it's a higher number, it's a thinner grain. If you overcharge with catalyst, you can get burned the material that you are seeing in the microscope, and you have to pass it another time in the sandpaper to eliminate that burn area.
In order to obtain the size of the grains following the ASTM norm, we use the photomicrographs and counted the number of grains. For the material of 6061, that is the aluminium, we use 100 zoom and we counted 12 grains. The formula to get the ASTM number is the number of grains equals to 2 powered to the n-1, where n is the ASTM number. Finally, we got for this sample 4 ASTMs. For the steel, 1018 we counted 9 grains, but we used a 1000 zoom, so we needed to get the number of grains before applying the formula, and the formula to get the number of grains is the zoom used divided by 100, and that elevated to the second power, and multiply that by the number of grains counted, and then we use that number in the formula, and we got that it has 10 ASTMs.
In this practice, we saw that the steel was more resistant than the aluminum. Why? Because when we saw in the microscope the grains, the steel have more grains than the aluminum.
Well, in this practice, I conclude that the bakelite is very important. All the process that follows the metal, it's very important to follow it in a good way. Also, I conclude that the steel is more resistant than aluminum because of the number and size of the grains.
Practice is very important because we determine the size of the grain of each material, and with this size we can know the properties of the material and the structure and the mechanical and chemical properties. Also, it's very important because each material can, with this size of the grain, we can determine the strain of the material to fissures or to cracks in the structure.
I believe that metallography is one of the most important tools to study the material's behavior, since with this tool we can see the grains and also calculate the size of them, and if we know the size of the grains, we know also which kind of properties does the material have.
We learned that we have to cut the metal in little size because we have large bakelite, and we have problems to put it in the bakelite maker.